Assalamualaikum and good day. Today, we, Group 18, will be going to present our findings on the outdoor air requirement for restroom. Before that, let me introduce my team. I will be the project manager. Alongside with me are two quality control engineers, ALIF HARIZ and ALIF Adam. Supporting them is HAFEEZ the analyst, NABIL from finance, and UZAIR the design engineer. First, problem statement. Restroom must require sufficient air circulation to support both normal and festive season, besides minimizing the transmission risk of coronavirus and reducing unpleasant smell. Therefore, in this research, we will identify the required air ducting unit, calculate the electricity cost, and suggest two alternatives to reduce the cost. Now, moving on to the introduction. For the procedures, we will refer to ASHRAE. First, we find the restroom area using occupant density. Then, we calculate the volume flow rate per air ducting unit, and this will be our supply. As for the demand, it is based on the outdoor air requirement. Then, we identify if the air ducting unit supplies sufficient enough for demand. All these steps 1 to 4 are repeated for the festive season. Next, the restroom floor plan is sketched. Then, the power consumption is calculated and all the findings are compared in the table comparison. Lastly, two alternatives to reduce electrical usage are suggested.
My name is MUHAMAD HARIZ, and today I'm going to show you how we calculate the requirement for the air ducting unit for the break room in the normal usage. So first we have to determine the occupant density in normal break room. So first, given for us the total number of occupants in normal usage is 7%. So using that information, we refer to table 6.1 minimum ventilation rate in breathing zone. We could determine the occupant density for 7%. So given for us is 25% per 1000 feet square or 100 meters square. So we have 7% here. So we use ratio to determine the occupant density for 7%. So we managed to determine it with the value 280 feet square. So now that we have determined the occupant density, we then need to determine the flow rate of ducting system. So for one air ducting, we are given diameter of 15 centimeter or equal to 0.15 meter. So we are assuming the air velocity to be the maximum, which is the 8 meter per second. So using the formula of volume rate, we can determine the volume rate per air ducting unit using the equation of flow rate is equal to area of the flow times with the air velocity. We then, using the information that we have, we determine the volume rate for one air ducting unit is 0.141372 meter cube per second. So we already determined the volume flow rate. Now we determine the breathing zone outdoor airflow. So what we have here is the equation for it, which is include outdoor airflow rate required per person times with zone population plus with outdoor airflow rate required per unit area times it with zone floor area. So based on the ASHRAE table that I have shown you before this, we already got all the value. All we have is just to add all the value into the breathing zone outdoor airflow equation, and then we got the value. So what we have here is 51.8 feet cube per minute, and we change it to meter cube per second, which is 0.02444688 meter cube per second. Now we have the breathing zone outdoor airflow value. So now we can determine the required air ducting that we need for the break room in the normal usage. So we have here is the breathing zone and also the flow rate of air ducting unit. So we treat the breathing zone as the demand in the break room for normal person, while the Q also the volume flow rate as the supply for from the adapter unit. So by that we can determine how much adapter unit that we are to determine to fulfill the demand of the break room in the normal usage. So we use the ratio over here, which is the breathing zone over or divide by the volume flow rate. So we have a 0.173. So the value is not exceed 1. So meaning to say that the demand is actually much lower than the supply. So we can conclude that the adapter unit is sufficient, or one adapter unit is sufficient for the whole room during the normal usage, which include only 7%.
Hello, my name is Alif Adam. So we shall go to the calculation for required adapting unit for festive season. During the festive season, there is an increment of 50% of the total number of 7 occupants. Therefore, the total number of occupants PZ is equal to 11%. To find AZ, we need to use the ratio of the occupant density as stated below. So finally, we got the number of AZ, which is 440 feet square. The flow rate of ducting system for both conditions are the same, which is Q is equal to 0.141372 meter cube per second. Based on the Ashray table, we can find the value of AZ, PZ, RP, and RA. Therefore, when we substitute this number into the VVZ, which is the breathing zone outdoor airflow, we got the final value is 0.03841652 meter cube per second. Finally, for the required adapting, when we divide the value of VVZ to the Q value, we got the answer is 0.272. Since Q is greater than VVZ, the supply air volume flow rate is exceeding the air flow required by the adapting. Hence, we can say that only one adapting unit is sufficient for the break room during the festive season.
My name is MUHAMAD, ROSLAN, the design engineer, and I'll be explaining the restroom sketching plan. As you may see, this is the restroom sketching plan. As for the design procedures for this plan is, first we assume the maximum occupant based on the festive season, as it is the highest occupant, and then from there we can find the area of the restroom, which is in this case is 440 feet square, and from there we design this restroom within that area. Now the second part is we design the restroom based on the occupant. As mentioned before, the occupant during the festive season is 11, so there should be about 6 toilets and 5 sinks to accommodate 11 people. For the location of the vent, we put it here at the left, as you may see the screen, as compared to the right side. We have a vestibule, which is the restroom area. It doesn't require a door, so it have enough proper ventilation there as well, so that should also cover the extra ventilation for the restroom.
Now on to the calculation for the annual energy cost. The amount of air ducting unit used is only 1, and one air duct unit consumes 50 watts of power. Since it's turned on 10 hours per day, in a day it consumes 500 watt hours of power. It is also turned on for 250 days per year, giving a total of 125 kilowatt hours per year. The cost for power is 0.126 euros per kilowatt hour. This gives us a total of 15 euros and 75 cents per year for this one air ducting unit. Now on to the comparison between the usage during normal days and during the festive season. Under normal usage, the occupancy is 7 people, whereas during the festive season, the occupancy increases to 11 people. Despite the increase in occupancy, the amount of air ducting unit used is still 1. Therefore, the electricity cost per year is the same, which is €15.75.
Now, let's see how can we reduce the electrical usage and cost. First, use fan with a high efficiency rating. The maximum efficiency of fans is generally between 60 to 85% depending on the type of fan. The higher the efficiency of the fan, the higher the amount of electrical energy converted into kinetic energy. Thus, less energy is used to ventilate the area. Secondly, use motion detector. By using this sensor, the ventilation system will be activated only when someone is using the space. Thus, electrical energy will not be wasted on ventilating vacant space. Reflection on this project. After completing this project, we have better understanding of thermodynamics application in the real world. This project also enhances our collaborative and communicative skills since we had many discussions in completing this project. That is all from us. Thank you for watching this video.